Now that's for a Bernoulli distribution, right? So we're not just going to look at that in extension 1, we're also going to look at this concept of binomial distribution. And what did I say was the distinguishing factor between these? Because I keep emphasizing it's one thing to just do the calculation, so it's another thing to actually understand and grasp kind of what's happening here, right? So they're going to use these a lot in your exercises, and it's important to distinguish what is the difference between them, right? So a Bernoulli distribution is just one instance, right? But the binomial distribution is like the distribution of that distribution, like distributionception. So it's just like a collection of these kind of trials, right? So it's like if you ran the experiment multiple times, yeah. How do you think that's going to affect these results? Because we are still going to find an expected value, and we're still going to find a variance, right? And if you want to think about what that formula might be, well, think about if you ran this multiple times, this particular experiment over here, right? What happens if I ran it 11 times? How many successes would you expect? 4. How'd you do that? You just by the probability of success, right? So you're multiplying the probability of success by the number of trials which you're doing. And that's essentially what's going to happen here with the binomial distribution. Because the idea is you're running the experiment, however many times, maybe 10, 50, 100. We don't know, right? But we know you're running it n times, right? So the idea is you just multiply these values here by n, and you're going to get the expected value for the binomial distribution. And if you multiply this by n, you're going to get the variance of a Bernoulli distribution. Yeah? Yeah, that's it. So, like I said, right, the calculations, I want to emphasize, are not going to be too involved. But what is kind of a little bit tricky is the way in which they phrase questions. You have to make sure you have a good understanding of what's actually happening here. What is this, right? This is really just a way to represent a function. It's like a table of values, right? But now we're translating that into probability. And that's the skill that we're looking at. So questions that they'll commonly ask will be something like this. Something I want to explain. In the beginning of this topic, I explained that one of the ways we can write our binomial distributions is using this notation. So this is your random variable. And these values here, these are your n and your p values, right? So n is the number of trials, p is the probability of success. Yeah. So that's all the values you need to find these guys, right? For example, the expected value, that's just n times p, so 15 times 0.3, right? That's going to tell me how many of a particular thing I can expect. So you got 5 of those guys, right? Our variance Angus, can you calculate that for me? So that's np times 1 minus p. So what's that going to be? 15 times 0.3 times 0.7. 3.15, cool. Yeah. What's this symbol here, though? Does anyone remember that one? Standard deviation, right. And the standard deviation, right, if you remember, is the square root of the variance. So it's not a given formula, but it can be derived, right, because you could basically say it's just the square root of np 1 minus p, or just the square root of that value that you found there. So just be aware that that's something they could ask you in a question like that, right? And someone put that in for me? What'd you get? 1.77. Perfect. That's helpful. All right, sorry, that capital B just means it's a binomial distribution. Because actually, what you'll learn if you do maths later on is that there's lots of different types of distributions, right? They're not just ones that look at successes and fails. We can look at, there's a whole heap of ones like Poisson, and the normal one is a different distribution that you guys learned about, right? So, I said poisson. So, en croissant. No, it's like fish in French. I don't know why they've chosen the word fish, but. Is it poisson? Okay. Yeah, I don't know. I'm very good at French. I kind of failed French in high school. So anyway, all right. That's not about Frenches. All right. So we have this information here, year 12, and the idea is the skill that you're doing is related to, predominantly for this skill, these formulas here, right? So you may be given some pieces of information and missing some. For example, here, we don't have the probability of success, but we do have the, what? Expected value, the average, right? And so here, what I can do is I can construct equations that relate to this, right? So we know that 5 is equal to NP. And Joel, what is N in this case?
N is 20.
Good. Yeah, so just being familiar with this notation. 5, yeah, P is P. 5 is equal to 20P, so P would equal to 1 over 4. So that's it, right? Yeah, I thought there was going to be more. And I just did that subconsciously. I was like, wait, I think that's the end of the question. Cool. This one over here, did anyone have a go? Yeah? What did you try, Joel?
I know, so I haven't done it.
Oh, okay. So that's a mu, sorry. But yeah, that's mean. Yeah. So like I said, just emphasizing, the skill here is relating to the formulas. Now, here we're not given N or P, but we are given those other statistical summaries. And Joel, what did you say that this guy is over here? Yeah, because it's the standard deviation squared, which you know is the variance, so it's just another way of representing that. And we have the mean. So where can we go from here? Any ideas?
Good question, that one.
Yeah?
Very good question.
What do you have to do?
Take the root of that and then
Yeah.
go back to the equation to get something.
So you want to take the square root of this one?
Yeah, can you do that?
Yeah? You can.
Yeah.
Is that what you want to do?
I don't know.
What is the square root of it?
It's a good question.
You can put it in the calculator.
What's the number? 6.3. And then could we do like a simultaneous with the other one?
Sure? Yeah?
You're saying sure, like we shouldn't do that.
I want you guys to help me out here.
I'm gonna stop talking.
So what's the square root of 6.3?
No, I stopped.
It's something. So how does that help? Work with me. What else we got?
Let's just write it in the formula.
Yeah? What's the formula?
The var equals.
Yeah? So the variance, and what is the variance?
The var.
The var. What is the var? 6.3 is equal to NP on minus P. Any other info we got?
Yeah, we've got the expected value.
Yeah. So the expected value is 9. So 9 is equal to NP.
Wait, that's what var means?
Yeah.
Couldn't just ignore me. Why'd you make me talk then?
Well, so then what? So
You're such a bully.
I'm not a bully. I want to hear all my students' opinions, right? And their input.
I missed out. I come here late.
I don't want to I don't want to shut people down. If they say something and it's wrong, I'm like, no, you're wrong. That feels way worse than letting them speak and then gently saying, oh, but actually what we want to think. Because why is this? Why don't we want to find this? Yeah, you're an exception. All right. So here, what James has found is actually the standard deviation or sigma. Yeah. So SD maybe. Right. And so what you'll notice though is if you just put your values into the formula, then what you can do is you can solve simultaneously.
Should we know that's what formula equals?
Sorry?
Like I didn't know var was that variance.
Okay,
That's
yeah.
what I meant, like,
That's right. So how might you want to do this?
And the subject equate.
Yeah. One thing that I actually did that, right? Make n the subject and equate. There's actually an easier way if anyone can see it.
Minus.
Just sub 9.
Yes,
NP.
that's exactly what it is. So what you notice, what Joel suggests is, hang on, you've got NP here, and you've got NP here. I actually didn't even see that because I've been so ingrained in simultaneous, like, oh yeah, make a subject, substitute it in, do some algebra. But you know, take some time, it's worth it, and just have a look at, oh, actually, all you need to do is substitute 9 into this, so you get 6.3
This is a way easier.
equals to 9, 1 minus, you don't have to deal with fractions or anything like that. In fact, I actually made a mistake when I did it by making the subject algebraically, so naughty. So go ahead and solve that, expand, and get a value for P.
What would you say?
No, you don't have to.
Well,
What, divide by 9, yeah?
0.7 is.
So this, wait, what, this is 0.7?
Imagine it as like 63 or something.
Ah, smart.
How does that happen?
And then,
Sorry,
yeah, I'm with you, man. 63 over 90, then Then you put in your calculator. makes it easier. B is equal to 0.3. All right. And then what else do you want to find? N. So substitute it back in. So you got 9 is equal to n times 0.3. So what's your n value there?
30.
3.
So 30.
Okay. Nice. N equals to 30. How do you feel about that?
Bad.
Not too bad? Want something a bit harder? So this is the idea with binomial distributions, right? These are the calculations we can do with the summary statistics.